I am here to get some some lessons in algebra, which is multiplying and adding some matrices. Let's go directly to the lesson. We have matrices here. If we have a matrix like that, a matrix A equals A, B, C, and D. Okay. If A equal A, B, C, and D, and we have another matrix here, B equals L, M, and N. This matrix is of order 2 by 2 because we have 2 rows and 2 columns. This matrix is of order 1 by 3. Is these two matrices can multiply by each other? It's no. Why? Because the number of columns here doesn't equal the number of rows here. It's an important condition to making multiplying of two matrices, that the number of columns of the first equals the number of rows of the second. So it's impossible to multiply AB here, or A multiplied B is impossible. But if we have another matrix A, B, C, D, and we have B equals only 2 rows like that, L and M, so this matrix of order 2 by 2, this matrix is of order, and here N, C, 2 by 2 also. The number of columns here equals the number of rows, so it can be to multiply A by B, A times B here, we have to multiply this row first by this column, and it gives only one element, A times L, AL plus B times N, and it gives like that, AL plus BM. And the resulted matrix will be 2 by 2 also. We have here the first one. So let's move to another example. The examples here, if we have A here like that, and A as a numbers 2 and 1, 3 and the negative 1, 0 and 4, and B equals negative 1, 2, 0 and negative 3. Ask myself, what's the order of this matrix? It's just 3 rows multiplied by or by 2 columns. This one 2 rows by 2 columns, and we have the number of columns here equals the number of rows, so it's possible to multiply A by B. To find the result of multiplying A by B, we just write AB equals, first you multiply 2 and 1 by negative 1 and 0. 2 multiply negative 1 equal negative 2, plus 1 multiplied by 0 equals 0. Negative 2 plus 0 equal 2. And we have also the same row multiplied by the second column. 2 times 2 equals 4, and 1 times 3 equals negative 3, so it's 1. And remember, my dear students, that the expected matrix will be 3 by 2, 3 rows and 2 columns. Okay, Let's move to the next row here. We'll multiply it by the first column. 3 times negative 1 equal negative 3 plus negative 1 times 0 equals 0. So it's equal negative 3. And the same row, multiply the second column here. 3 times 2 equals 6. And negative 1 times negative 3 equal 3. So it's 9. And the final row here, multiplied by the first column. 0 multiplied by negative 1 equals 0 plus 4 multiplied by 0 equals 0. So the sum equals 0. And this row will also multiply by this column. 0 multiplied by 2 equals 0 plus 4 multiplied negative 3 will be negative 12. And the order of resulted matrix now is 3 rows times 2 columns. Okay. And it's possible to do multiplying because the number of columns here equals the number of rows here. This one, these two numbers are equal. Okay. Let's move to another example. If we have AB now, number 2, if A equals 1, 2, 3, 1, 0, negative 2, and the matrix B will be 1, 5, 3, negative 1, 2, and negative 4. Is it possible to multiply A by B? We'll investigate now. We have here the order of this matrix: 2 rows by 3 columns, and this one is 2 rows also by 3 columns. Here the number of columns doesn't equal the number of rows, so AB is impossible. We have here the number of rows here, columns here doesn't equal the number of rows, so it's impossible to find the multiplying of A times B. Let's move to another example. If we have another A, example number 3, A here equals 1, 2, 3, 1, 0, negative 2. And of course, this matrix will be 2 rows by 3 columns. And we have the other matrix B, which is 1, 5, 3, 1, 5, 3, and negative 1, 2, negative 4. Find if possible A multiplied by B transpose. Okay, we will find B transpose here. B transpose, as you see, the row will be a column. First row here will be the first column, so we put it like that, 1, 5, 3. The second row will be the next column, negative 1, 2, and negative 4. And the order now is 3 rows multiplied by 2 columns. Here we have the number of columns equals the number of rows, so it's possible to find the multiplying the matrices. So AB equals, let's put A like that, 1, 2, 3, 1, 0, negative 2, and the other B transpose will be 1, negative 1, 5 and 2, 3 and negative 4. Concentrate with me. We will multiply this row by this column, and it will be only one element. The order of this matrix, as we said, 2 by 3, and this one 3 by 2. So it's expected to be 2 by 2 column matrix. Okay, let's multiply this row by this column. 1 times 1 plus 2 times 5 equal 10, plus 1 equal 11. 3 times 3 equals 9. 9 plus 11 equal 20. This row multiplied by this column. 1 times negative 1 equal negative 1. 2 times 2 equal 4. 4 plus negative 1 equals 3. Plus 3 times negative 4 equal negative 12. Okay, again. 1 times negative 1 equal negative 1. 2 times 2 equals 4. 3 times negative 4 equal negative 12. So the answer here will 3 plus negative 12 will be negative 3, negative 9. Okay. And we have also this row multiplied by this column. 1 times 1 equals 1, plus 0 multiply 5 equals 0. Negative 2 times 3 equal negative 6. So the answer is negative 5. And this row multiplied by this column also. 1 times negative 1 equal negative 1. 0 times 2 equals 0. Negative 2 times negative 4 equals 8. So it's 7. Okay. As we expect, it's 2 by 2 order of this matrix. And we have multiplied A times B transpose. A times B transpose. Okay. Let's move to another question. We have another question for you. If we have A here equals 2, negative 1 and 3, and we have B equals negative 2, 1 and 4, the order of this A matrix will be one row multiplied by 3 columns. The order of this is 3 rows multiplied by 1 column. And now we have the columns here, number of columns equal number of rows, so it's possible. Okay. Let's find AB now. The expected order will be 1 by 1, just one element. 2 multiplied by negative 2 equal negative 4. Negative 1 times 1 equal negative 1. 3 times 4 equal 12. So negative 4 plus negative 1 equal negative 5. Negative 5 plus 12 equals 7. So just 7. One element, because it's one row, one column, means just one element. Okay. We have another example. A here equals 4, negative 3, 2, negative 1, and B equals negative 2, 1, 5, and 6. And we have C also equals negative 2, 0, 0, negative 2. Find number 1, AB and BA. Okay. First, we will try to find if it possible to find AB or not, and also BA. Okay, AB equals what A? What is the order of B of A? Is 2 by 2. B 2 by 2 also. Okay. We have 2 by 2 and 2 by 2. So here 2 equal 2. It's will be possible to find AB. Okay. And it will be 2 by 2 also. So will be 2 rows and 2 columns. Okay, let's move to multiplying. We will multiply 4 and negative 3, the first row by the first column. 4 times negative 2 equal negative 8, plus negative 3 times 5 equal negative 15. So now it's negative 23. The first row by second column, 4 times 1 equals 4, plus negative 3 times 6 equal negative 18. So the answer will be negative 14. And the second row by the first column here, 2 by negative 2 equals negative 4. Negative 1 times 5 equal negative 5. So will be negative 9. This row multiplies the second column. 2 by times 1 equals 2, plus negative 1 times 6 equals negative 6. The answer will be negative 4. And the question is AB equal BA? We have AB here, negative 23, negative 14, negative 9, and negative 4. If we try to make multiplying of BA here will be BA means we will multiply first row here by the first column here. Negative 2 times 4 equals negative 8. 1 times 2 equals 2. So the answer equals negative 6. We have here negative 6. We will complete multiplying, but from now AB here doesn't equal BA, because as we see first element here, which is A11, is different from A11 here, which is negative 6. So the answer of course will be different. So we can say that AB doesn't equal BA. Okay, let's move to another example. We have many examples. To find out the properties of the matrices now. First, associative property. Associative means that if we have a matrix A plus a matrix B plus a matrix C, and we add B plus C together, the answer equal A plus B here plus C if we add these together. But this is in addition. What about multiplication? In multiplication, we can multiply AB, and the answer will be multiplying by C, and it is equal A multiplied BC. Okay. What about, this is associative. What about multiplicative identity? We have I, which is like this: 1, 0, 0, and 1. It's a unit in matrices. And if I multiplied by A here, 2, 3, 1, 5 as example, what happened? Multiply 1 and 0 by 2 and 1. The answer will be 1 times 2 equals 2, and 0 times 1 equals 0, so it's 2. This row also multiplies this column, so 1 times 3 equals 3, and 0 times 5 equals 0, so the sum equals 3. And we will multiply this row by this column also. 0 times 2 equals 0, and 1 times 1 equals 1, so it's 1. And this one multiplies this column. 0 times 3 equals 0, and 1 times 5 equals 5, so the answer equals 5. This is I multiplied by A. And the answer, if we investigate, equals A multiplied by I, so it's A itself. Okay. If we have also A plus B multiplied by C, the answer will be AC plus BC as a distributive property. Okay, and if we have C here, okay, C times A plus B will be CA plus CB. Okay, okay. And we have a question now to check the multiplying and distribution. Check if A here equal a matrix like that, 1, negative 2, negative 0 and 0, and we have B another 1, 3, negative 5, negative 1 and 2. Okay, we have A and B like that, and we will find A multiplied by B plus C, and we have also a matrix C equals negative 2, 6 and 1, negative 1. And now we will investigate if A multiplied B plus C here equals AB plus AC. Is it right? Okay, let's first find B plus C. B plus C here means that we add 3 plus negative 2 equals 1, negative 5 plus 6 equals 1 also, negative 1 plus 1 equals 0, 2 plus negative 1 equals 1. So we have B plus C equals 1, 1, 0 and 1. And A multiplied B plus C now equals A here. We have the row multiplied the column. 1 times 1 equals 1, negative 2 times 0 equals 0, so it's 1. And 1 times 1 equals 1, and negative 2 times 1 equals negative 2, the sum equals negative 1. And by multiplying the second row, okay, the first row here, we multiplied with the first column and second column. The second row multiplied by the first column here, negative 3 times 1 equals negative 3, and 0 times 0 equals 0, so it's negative 3. Negative 3 times negative 1 equals negative 3, and 0 times 1 equals 0, the sum equals negative 3. So A multiplied B plus C equals this matrix. And let's move to find AB and AC. AB means A multiplied B. 1 times 3 equals 3, negative 2 times negative 5 equals 10, so it's 13. 1 times negative 3, negative 5 equals negative 5, plus negative 4 equals negative 9. Okay, and this matrix, this row multiplies this column. Negative 3 times 3 equals negative 9, plus 0 equals negative 9. Okay, and this one multiplies this one. Negative 3 times negative 5 equal 15 plus 0 equals 15. Okay. If we multiply here this row by this column, 1 times 3 equals 3, and negative 2 times negative 1 equal 2. So the answer is 5 only. Okay. Let's multiply A by C. This row times this column. 1 times negative 2 equal negative 2. Negative 2 times negative 1 equal 2. So it's 0. Okay. And this row multiply this column. 1 times 6 equals 6. And 2 equals 8. This row by this column also. This row by this column. Negative 3 times negative 2 equals 6. Plus 0 equals 6. And this row by this column. Negative 3 times 6 equals negative 18. Plus 0 equals negative 18. To find AB plus AC, you will find that the answer will be like this. Something wrong in the numbers, but the answer will be the same as A times B plus A times C. So the answer will be 1, negative 1, negative 3, and negative 3. Okay, so A multiplied B plus C will be equal AB plus AC. Okay, if we have fault about numbers, I apologize, but the answer will be correct. Okay, let's move to another question now. If we have determinants, let's go to the determinants directly. What is a determinants? Determinants. What is determinant? Determinant, if we have a matrix here, okay, determinant, if we have a matrix here like that, 2, 1, 3, negative 1, and we will find its determinant like this equals determinant of this matrix 2 and 1, negative 1 and 3. 2 times 3 here, we'll find 2 times 3 the first principal diagonal, 2 times 3 minus 1 times negative 1. Here equals 6 minus negative 1 equal positive 1, so the answer equals 7. Yes. No, yes. My dear students, let's go to little break and we'll return again. Let's move directly to determinants. What is a determinant? Determinant is a square matrix, 2 by 2 or 3 by 3 only. We cannot study more than that in our studying. So if we have a matrix A here like that, A, B, C, and D, and we want to find the determinant A, it will be equal like that. Put vertical lines. It's A, B, C, and D. Okay. To find the value of this determinant, we have to multiply the principal diagonal minus the other diagonal equals A times D equals AD minus C times B equals CB. So the determinant here is a square matrix. Square matrix can convert into a determinant. It's now 2 by 2 matrix, and this determinant equal 2 by 2 or second degree determinant. We have another determinant if we have A here equals a square matrix like that, A, B, C, D, E, F, G, H, Y. If we have a matrix like that, it's a square matrix and it's a 3 by 3 matrix, and we can find its determinant, which will be the same elements A, B, C, D, E, F, G, H, Y. So it's the third degree determinant. And we have said that we have determinant here. If we would like to multiply to find its value, we multiply the in principal diagonal minus the other diagonal. So A times D equals C minus times B. But this determinant, we have many steps to find out it. Now, if we have this determinant, then concentrate about the sign. We have plus here, okay, and plus here, and we have negative there. Try to concentrate about and pay attention to this sign, because if we find out the determinant value, we have to find it by using one of these rows or one of these columns. Okay, first we will go to find determinant of some small determinants, which is second degree determinant. Find the value of the first determinant for -7, 2 and 6 equals 4 times 6 equal minus -7 times 2, and the answer will be 4 times 6 equal 24 minus -7 times 2 equal -14 multiplied by negative equal +14. The final answer will be 38. We have another determinant to find, this one, 6, 3, -8, -4. We will find also the principal, principal which we have 6 multiplied by -4 minus 3 times -8. 6 times -4 equal -24, and 3 times -8 equal -24 also multiplied by negative equals +24. The answer will be 0. Okay, we have some other questions here. Find the value of which satisfies the determinant x power 2 minus 4, here 1, 0 and 1. This determinant equals 0. We have the value of this determinant equals 0, so we'll use the definition. If we multiplied x power 2 minus 4 multiplied by 1 will be x power 2 minus 4 minus 0 times 1 equals 0, and the answer will be 0 as he said. So we have now x power 2 minus 4 equals 0, and if we put x power 2 equal 4, and x will be positive or negative square root 4, so x now equals positive or negative 2. So this is the answer. X now equal positive or negative 2. Let's move quickly to another question. If we have a determinant like that, x plus 2 and another one 3, -2 and x minus 2 equals 1, find x. We will multiply x plus 2 times x minus 2. You will have x power 2 minus 4 minus what? 3 times negative 2, negative 6 equals 0. So x power 2 minus 4 here plus 6 equals 0. So x power 2 plus 2 equals 0. X power 2 here equal negative 2. So x equal positive or negative square root negative 2. X here equal positive or negative 2 root 2 I. I is imaginary number. So solution set in R will be phi, but in complex numbers will be root 2i and negative 2 root 2i. Okay. Let's move to another question. If we have a matrix like that, or determinant like that, 2, 3, negative 1, negative 2, 0 and 4, 1, 1, negative 3, and we would like to find out the result of this determinant. And if we decide that we will find it by using this row here, first we have to put the number 2 and cancel its row and its column to multiply it by 0, 4, 1 and negative 3. Do not forget, my dear friends, that the sign here positive, negative and positive. So we have minus 3 times, here we have to cancel the first row and the we have the cancel the row and column of 3, and the determinant will be negative 2, 4, 1 and negative 3 plus the last one negative 1 times, we have to cancel the row of negative 1 and its column, so the remainder negative 2, 0, 1 and 1, and try to find the answer now. 2 times what? 2 times 0 times negative 3 equals 0, minus 1 times 4 equals 4, minus 3 times negative 3 times negative 2 equal 6, minus 4 plus times negative 1 times negative 2 times 1 equal negative 2 minus 0. So the answer will be negative 8 here and minus 6 plus 2. The final answer will be negative 12. Okay. Let's move to another question. If we have a determinant like that, we have determinant now 4, negative 1, 3, 0, 5, negative 2, 0, negative 3, negative 1. To find the value of this determinant, we can use the first row, the second row, third row, or first, second, third column. I found that it's easy now to find it using this column. Why? Because we have just one number and the other we have zeros. But don't forget that if we use this, we have here the sign positive, 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 okay, and the other will be negative. So if we will use this column, the first will be positive, second negative, and third will be positive. So okay, so we will use this one 4 times. 4 times what? We will cancel its row and its column. It will be 5, -2, -3, and -1. We have here zeros, so we can put -0 times determinant plus 0 times another determinant. If we write them and find them multiplied by 0, will be 0. So we can cancel this part. The final answer will be 4 times the value of this determinant. Now the value of this determinant is 5 times -1 equal -5, minus -2 times -3 equal 6. So 4 times -11 equal -44. So the final answer will be -44. Okay, let's move to another example here. If we have a determinant like that, x 0 1 8 1 minus 8 negative x, x -1 1 plus x, okay, and it is equal 0. The request is solve the equation. Solve it. Solving the equation is to find the value of x. We have to find the value of this determinant, and we will choose the first row. It's easier because we have 0 here. We'll cancel the middle term. X here multiplied what? X multiplied determinant. Determinant cancel this row, this column, and this row. So it will be, here is 1 minus x. Here will be 1 minus x. This is negative x, -1, and 1 plus x. This is the first row and first column multiplied by x. Minus 0 multiplied by a column. Determinant will be 0, of course, so no need to write it. Plus 1 multiplied. We cancel the first, the third column and first row to write 8, 1 minus x, x, and -1. And if you like to write this determinant, cancel the 0 column and row. Will be 8, -x, x, and 1 plus x. Now this part will be equal 0. We will concentrate about this one. X multiplied what? This principal diagonal. 1 minus x times 1 plus x will be 1 minus x power 2 minus -x times -1 equals x, and this one will be 0. The last one be 1 times this determinant. 8 times -1 equals -8 minus x times this one, x times x equals x, x times -x equal -x power 2. We will try to find the result of this. X multiplied by 1 multiplied by x power 3 multiplied by x. X times 1 equal x minus x times x power 2 equal x power 3. X times -x equal -x power 2. And we have -8 here. And negative times x equal -x. Negative times x power 2 equal positive x power 2. And we can cancel -x power 2 plus x power 2. And we cancel also -x with x. The final equal -x power 3 minus 8, which equal, of course, equal 0 because this determinant equals 0. So we have x power 3 negative x power 3 minus 8 equals 0, and we can multiply it by 0 by negative 1, so x power 3 plus 8 equals 0. And by factorizing this as sum of two cubes, we know that the sum of two cubes will factorize like that. We can factorize it here, x plus 2 multiplied by x power 2 minus 2x plus 4. All of them equal 0. Okay. We have here x plus 2 multiplied this bracket equals 0. We know that this part equals 0, but this part doesn't equal 0 from last students. And if we have x plus 2 equals 0, so in real numbers x equal negative 1, negative 2, and solution set equal negative 2. Okay, we can move to another example. How to find the area of triangle if we have A, B, C, the three points of the triangle. If we have a triangle here like that, A, B, C, and we have A equal, as example, 1 and 2, B 3 and negative 4, C will be negative 2 and 3. If we have a triangle in the coordinate axis like that, and we want to find its area by using determinants, the rule is to find the area of triangle ABC equals what? Equals half the determinant, and try to write 1, 1, 1, okay, and write the point A itself, 1 and 2 here, and B 3 and negative 4 here, and C negative 2 and 3 here. So we have this rule, half multiplied by a determinant. This determinant contains the last column of ones, and the point A 1 and 2 here, the point B 3 and negative 4 here, the point C negative 2 and 3 here. And if we find the value of this determinant multiplied by half, we will find the area of the triangle. Let's go now. Let's the area of triangle equal half multiplied by what? Half times. First we have 1 times the determinant, cancel the column of 1 and row of 1, will be negative 4, 1, 3 and 1, minus 2 times, cancel this one, okay, cancel this row, this column and this row, will be 3, 1, negative 2 and 1, plus the last one is 1 times the determinant 3 negative 4 negative 2 and 3. Okay, the answer will be half multiplied by, will be found that negative 7 minus 2 times 5 plus 1, and the final answer will be negative 8, but we will have the positive number because it's area. So the area of triangle equals 8 square unit. Okay, we are finished now. My dear students, it's my pleasure to meet you today, and we have finished. Until we meet next Friday, happy day to you. Thank you. Goodbye.